So our end goal is to graph the following graph here that I put in the blue box. It has a 1/4 out in front, then a 2, then a +3, then a +4. And we're starting off, excuse me, we're starting off with just y equals the absolute value of x. And then figuring out how do we get from that red graph to the blue graph. So if we go through all of these little graphs that they've put along the way, if you look at this graph first, it has the 2 inside. Would that affect the x or the y? It would affect the x because it's inside, and we multiply the x values by 0.5 or a half. This 1/4 out in front would multiply your y values by 1/4. So in the second graph, you'd have to multiply your y values by 1/4 and multiply your x values by a half. In the third graph, they got the 1/4, they got the 2, but they added the +3. That's going to move it 3 to the left. And finally, in the last graph, which we have, the only thing added is a +4, so that would add 4 to the end. Now, there are a couple of ways to go from the red graph to the blue graph. One way is to graph each thing separately, one at a time. And then you'd have like 6 graphs in the end and finally finish with your last graph. I asked my class this morning how many people in math find that graphing is their favorite thing. If there's one thing in math that I like the most, it's graphing. Okay, good. We have no abnormal children in this class. Normally, yeah, graphing's not your, I mean, you might have no favorite math things. I'll have to work on that. But graphing is usually not the favorite thing for math. It takes time, it's tedious, it takes up a lot of space. So if I said, for these questions, we're going to create 1, 2, 3, 4 graphs before our final graph, you'd be like, this sucks. And I would agree. It would suck to graph that many things. Plus, if you graphed all of those on the same graph, things would get very complicated and very big. So what we're going to do is we're going to go from the red graph, and we're going to start by graphing your parent graph. So here, I know that the absolute value of x, whoops, that's not red. There we go. I know that my parent graph, my absolute value of x looks like this. Then underneath your equation, you're going to go from left to right, just like you would read, and make a little note of what each thing does. So the 1/4, that multiplies y by 1/4. The 2, that multiplies x by a half. The +3, that moves 3 to the left. And the +4 moves 4 up. And in the last section, when we did our vertical stretches, we chose points, and then we wrote above the arrow, I'm going to multiply x by 3 or x and y by 2, and then find the new points. We're going to do something similar here, but we're going to have 2 sets of arrows. We're going to deal with all of our stretches and reflections first and figure out what happens after that. And then we're going to deal with all of our translations second. So we're going to choose some points to start with. And then do stretches and then translations. So now when choosing your points on your red graph, that is a key point. You're going to have to choose 0, 0. But when choosing your other points, you've got options. Now, sometimes people right away just say, I'm going to choose that point there, 1, 1, because that's the first point I think of. That's not a bad thing, except when you're choosing your points, I also want you to think about what we wrote here. All the things we're going to do to that point. In particular, I want you to see if you can, your life is going to be easier if you can avoid fractions. If I choose 1 comma 1, can you see when I multiply y by a quarter, I'm going to have a fraction. So when choosing my points, I'm going to say, can I think of a point, so when I have to multiply y by a quarter and x by a half, that I can avoid fractions? 4 comma 4. And similarly, I'll pick a point on this side, so negative 4 comma 4. Those points would avoid fractions. So we take those 3 points, negative 4 comma 4, 0 comma 0, and 4 comma 4. And we set up an arrow first, and we'll get new points after our stretches, and then we'll set up an arrow again, and we'll get our final points after our translations. Stretches and compressions first. Above these arrows is where you're going to write, I'm multiplying y by a quarter, I'm multiplying x by a half. And do that to each of those points. So I'll get negative 2 comma 1, 0 comma 0, 2 comma 1. Above your second set of arrows is where you're going to show your translations. So I'm going to write above this that I need to go 3 to the left and I need to go 4 up. If I'm at negative 2 and I go 3 to the left, I'll end up at negative 5. If I'm at 1 and I go 4 up, I'm at 5. If I'm at 0, 0, I go 3 to the left, I'm at minus 3. 4 up, I'll be at plus 4. And 2 comma 1, if I go 3 to the left, I'll be at minus 1. And up 4 plus 5. So now we're going to graph this. We've got a little piece of graph paper there. We're going to graph it separately, not graph it on the same one. I find that generally that makes things easier to see and you make less mistakes. So if you set up your axes, and I'm just going to do what you would probably naturally do, is just set up your axes right in the middle and then plot my points. So I've got negative 5, 5, negative 3, 4, negative 1, 5, and graph it. And you may notice that, oh, it's way off, almost off my graph completely. So another thing that you could do before you graph it, same thing that we did before we chose our points, is think a little bit about what it's going to look like. If I have to plot those points, maybe it would have made sense to move my axis down over here. And then my whole graph would have been moved down this way as well. But it's not bad. Here. So is it, what did I do? Right there. That one over there. It's not bad that we graphed it like this. It's not a wrong graph. But those are some of the things that we can do to think about before we graph.